So now I would like to introduce you the neutron scattering and applications. The neutron scattering actually is complementary with the synchronous radiation for study material structure. Synchronous radiation uses X-ray to detect the electron charge. And the neutron scattering interacts with the nuclei with the spin to study the structure and the dynamic behavior of the matter. The neutron scattering could detecting the material magnetism, detect the position of the nuclei, sensitive to light elements and isotopy, and could detect a large sample because the neutron have high penetrating. And also, neutron could detect the dynamic behavior in the matter because the neutron has appreciate energy momentum relationship is similar to the many motion in the matter. So I will give you some details. For example, only neutron. I think one of major advantages is the neutron has a spin, and it can study the magnetic structure of the matter. Like we can study the collective magnetic excitation, and also study spin fluctuation in the complex fluid, soft matter, low dimension system, non-fermion liquid, and so on. So that's some typical results for the spin excitation in the quantum magnet. And the neutron scattering in the condensed matter, they have widely to study the superconducting high TC superconductor. This is the direct probing the bond structure and the Fermi surface in the high TC. Because the neutron scattering is sensitive to oxygen, so this could give a much more detailed picture structure about the high TC superconducting. Also, this is another result to study the high TC superconducting. This is a classical work, spin wave of this kind of high TC superconducting material. Neutron scattering could probe light elements. You can see this plot. So this is the cross-section to the X-rays, different elements. This is the cross-section to the neutrons. So for the light elements, the neutron scattering has a much larger cross-section and could provide more detailed structure. For instance, this is a proton structure. So this is, if you only use synchrotron radiation, you get such kind of picture. If you combine with the neutron scattering, you will have much more rich information about this kind of proton. And this is for the high TC superconducting, and this is another proton. So they give much more rich information. Also, for the flammable ice, that's a very interesting new energy source. So those kind of material is in the deep ocean, high pressure. When you study this kind of material, you must be using a vessel with a high pressure. Light source cannot penetrate the vessel. Only neutron could penetrate. And also, those kind of material is the carbon, hydrogen. So the neutron scattering is sensitive to the carbon and the hydrogen. So that's I think this is also is very important work for the flammable ice. And also, this is the neutron application on the energy solid oxide fuel cell. They can give much more detailed information in situ to study those kind of new type of the battery. And this is for the hydrogen storage. Use the metal organic framework. So this kind of work also can, because the neutron has large cross-section with the hydrogen. So you can study very detailed information about those kind of hydrogen storage. That's the widely used method. This is the lithium battery in situ studied by neutron scattering. They can, I think this is Xunli Wang work. So they put the battery in the neutron spectrometer and with the many cycles of the charge and discharge and study the performance of the battery and optimize the design of the battery. Also, the neutron scattering has widely used in the soft matter study. So this is just give in the different scatter of the soft matter, and they widely use the neutron scattering for in this scatter. We have to use the neutron scattering to the soft matter study. Let's just give some example. In the biomaterial, different type of the biomaterial, and they produced many interesting results. And another advantage of the neutron scattering is the neutron has bigger penetrator power. They can study a large component. German ICE had a big accident at 1998. So finally, to understand what's happening with the accident, actually is the wear, the railway wear is the problem. So this was studied in the ICEs, in the spallation neutron source in the Rutherford, UK. So from this study, they understood what's happening with the wear and how the accident happened, and they find a way to avoid such kind of accident happening again. And also, we could in situ to measure stress and temperature of the metal. So this result also is from the Xunli Wang in the Oak Ridge, the US spallation neutron source. So the friction stir welding is a new type of the welding technique. So they are widely used in the many high-tech components. So to understand what kind of parameter we should use for the friction stir welding, we have to put the welding machine into the neutron spectrometer and in situ to measure the stress and the temperature distribution during the welding, and finally to optimize the parameters. This beautiful work, this also is a pioneer work, was carried out by Xunli. In the ICES, the UK, another interesting result is they just take a part of the Airbus 380 wing to study the welding and the rivet technique. Means they can study the stress distribution during the welding and the rivet, finally to optimize the technique. So I think that also is very interesting applications. Another interesting is to study the thinning, shear thinning liquid is a thick, complex liquid. So from the tomato ketchup to the salmon type of oil. So they can use the neutron scattering to study those kind of thick, complex liquid. So actually, they have many interesting applications. So this plot just show they show the wavelengths of the X-ray and the neutron, the energy and the energy of the neutron and the X-ray. So you can find the X-ray with the same wavelengths. The X-ray, actually, the energy is too high compared with the dynamic process in the matter. But the neutron, the energy, actually is matched with the material dynamic behavior. So that's why the neutron not only study the structure of the matter, also could study the dynamics of the many processes in the matter. So this plot just show if you study the structure for a different scalar, what kind of technique in the neutron scattering you will use. So for the large scalar, you can use the neutron imaging, and then use the very small angle neutron scattering, and so on. Finally, use the power diffractions for the picometer and the nanometer. So this just show different scalar, and also show different dynamics, the time scalar and the energy transfer for the different region. You will use the different neutron scattering technique to study the dynamics of the matter. So those is show the very powerful. The neutron scattering has two types of sources. One is a nuclear reactor, which already used for more than 50 years. Another is spallation neutron source. Spallation neutron source is based on the accelerator, high power proton accelerator. So the spallation neutron source has the advantage is the high pulsed neutron flux. So the average flux reactor is bigger. However, if we want to study many processes, we need the pulsed neutron. And the spallation neutron source provide much higher pulsed neutron flux. Also, the rich short wave of the neutron, and they have a super very good pulse time structure, very low thermal power, and very low background. The most important is free from nuclear fuel. Nowadays, is hard at Europe is harder to find a place to build new reactors. So the neutron scattering study eventually moving to the spallation neutron source. So this lists the spallation neutron source in the world. The first spallation neutron source is in the US at the Argonne Lab at 1981, called intense pulse neutron source, is 7 kilowatts. So it close after Oak Ridge neutron source started operation. In the UK, in the Rutherford, there is the ICES, is a neutron spallation neutron source, starting work at 1985. This neutron spallation neutron source actually is the most successful neutron source in the world. They produced many results, many first-class results, and also the many applications. The U.S. spallation neutron source is at Oak Ridge, it will be 2 megawatts. Japan has a JPAC at Jerry. In the future also is 2 megawatts. But at the meantime, they only reach 350 kilowatts. And China's spallation neutron source, it will open to use at 2018. So first, in the first stage is 100 kilowatts, and it will be upgraded to 500 kilowatts. I will give more detail about it. And at Sweden, Lund, the European spallation neutron source is under construction, hosted by Sweden and Denmark. They, host country, provide half funding, and another European country provide another 50% of funding. So they claim is 5 megawatts, but it's a long wave. So it's not directly compared with the 2 megawatts here.